Hello, everyone. Thank you for joining our talk today. I'm Hema Veeradhi, and joined with me is my colleague Yuan. We will be talking about AI agents and share our experience and insights into some of the work that we've been doing in this space. So, I work as a data scientist at the emerging technologies team at Red Hat. I'm currently located in Sunnyvale, California, although I've been in Boston for 5 years, so it's great to be back. And if you want to connect with me, you can find me on LinkedIn, and I'll let my colleague introduce herself.
Hi everyone, I'm Yuan, also from the Emerging Tech team. I'm a senior AI engineer here at Red Hat. I'm based in Dublin, Ireland. You can also find me on LinkedIn.
So in today's session, we want to quickly cover a couple of things, starting off with a little bit of an intro to AI agents and some of the problems that we're seeing with it, and what are some ways that we can build better, robust AI systems and overcome those issues, introduce you to the concept of MCP, or Model Context Protocol, which we will focus more on this talk, and then walk through a use case followed by a demo to show you the implementation, and finally wrap up with some lessons and key takeaways for you all, followed by questions. So for the past year, we've all been captivated by what AI can do or what it can generate. And we've seen it create some stunning images, build some insightful emails for you, help you summarize things, even produce code. And it's been great, right? We've all had some fun with it. But the next frontier is all about what AI can perform. So essentially, we're entering the era of AI agents. And I'm sure, like, if you're like me, you might be overwhelmed by it, and sometimes also freaked out that it can do a lot of things. But that is the reality that we're living in as of today. And in fact, the image on your left is actually generated by Gemini. So when I asked it, can you tell me what AI agents is and give me an image to describe it, that's what it gave. It's basically telling me that it's a world where you can do a lot of things on the go. So it's like imagining yourself walking on the street, just hanging out, and you want to book a flight somewhere to some trip. So it's basically saying that you can do this wherever you are, be able to look into the flights and calendars, and just like talk to the agent wherever you're at. So initially, we were interacting with these AI technology through chatbots. So we started using ChatGPTs and Gemini models and so on. And you basically interacted with it by giving a prompt, and you got some output generated from it, right? But so it was like a back and forth kind of conversational scenarios that you were looking at. But now an AI agent is going a bit further in the sense that it's actually, you can delegate tasks to it, and you basically are giving it the autonomy to do those tasks on your behalf. So things like booking a flight or looking at your calendar and sending automated emails and things like that, all of which is capable by these AI agents. So what does it really mean when we say an agent? It's more than just a chatbot. It's an autonomous system that can perceive, plan, and act in a certain way to achieve some goal-oriented task. So there are mainly three or four things that it can do. It can observe, think, act, and reflect. So what it means is that it operates in a continuous loop. So it first observes its environment. It then thinks about the task that you're giving it, and then using an LLM, which is basically the engine or the brain of it all, it tries to create a plan, and then it acts upon that plan and does an execution of a task that it was directed to do. And finally, it'll reflect about it and try to incorporate some feedback, and it takes in some inputs so that it can do better in the next iteration when you're interacting with it. So it's usually talking to some kind of an external environment, which we refer to as tools. So a tool can be your internal database system. It can be some kind of a web API service. It can be like Gmail. So these are all different tools that the agent has access to in order to actually perform and do those tasks that you want it to do. So for example, like that travel booking example that we saw, it's basically tapping into your calendar, it's pulling out information from Google Flights, and so on. And those are all what we refer to as tools. It has a memory component. So as you can imagine, there's a lot of context that you're giving it by using and interacting an LLM as the backend. So it needs a pretty stable and robust memory so that it can manage those interactions. And finally, it will go ahead and perform those tasks based on the output of the tool. It'll try to process it, and then it'll try to make those goal-oriented decisions and tasks that you've asked it to do. So all of this is possible today primarily because of the reasoning power of LLMs. So that is, agent is kind of a buzzword, but it's essentially just making use of LLMs and extending it beyond just chatting and conversational, but connecting it to all these external services and systems that you have available. So while the promise of agents is immense, there are some problems with it. AI agents are often very brittle. So the more you interact with it, the more you can see certain issues or types of failures that you can run into, especially if you're trying to scale these into production, which we're all now experiencing in different companies. We have different use cases. So the moment you get into enterprise level applications, they do tend to break. So when I mean break, these are some 3 types of failure modes that we have observed in our team where agents require more work to be done for it to be more robust and scalable. So the first one is what we call as the reasoning failures. So the brain fails, which is the LLM itself. So the LLM itself can have certain issues which we often refer to as hallucinations. So just like it means hallucination is when the LLM makes up facts or some illogical plans. Let's say your query or your task was book me a flight from New York to London, and it eventually books it, but via a train to Los Angeles, and then tries to come up with like a flight after that. So it's trying to do what your task is, but it's on the way sort of losing track of the goal, and it ends up going into some kind of a failure state where it's imagining or making up facts which may not be true. So that's one place where it can fail, and since the agents are using or relying on the LLM to do these actions, this is one place where there is a possibility of it failing. Then secondly, it can get stuck in some repeated loops. So what I mean by this is sometimes it tries to keep doing the same thing over and over again. You might have also experienced this when you try to talk to it about a certain task. It may not always end up in the right state because it's just oftentimes repeating itself. And this is what we say when it's getting stuck in a loop. And finally, it can also drift from the original task. So if it's a fairly complex and long task, it can also lose sight of the main objective, and it tends to focus on very irrelevant or sub-tasks which are oftentimes incorrect. So this is what we mean by goal drifting. And second type of failures that we see is the tools themselves fail. So basically the hands which we are using for the agent to make use of those different external resources and systems that we're connecting the agent with. So one type of common failure is wrong tool selection. So oftentimes when you build these agent systems, you're connecting it with various number of tools. So the more number of tools you're connecting it with, the more it has to think about what tool is the right one to invoke to perform that XYZ task. So for example, it tries to use a calendar tool instead of an email tool to like do your automated email. So this is a fairly common thing that we've been seeing. There are ways to mitigate this, which we will talk about, but this is one place where the tools can become a problem for the agent. Secondly, the input to the tool itself. So when you're interacting with n number of tools, every tool has a certain input format that it expects. So let's say I want to use a calendar tool because I'm asking the agent, look at my calendar and figure out what is the slot available and send out an automated email to set up a meeting with my team, right? So for this, it needs to look at your calendar, so it tries to look at the dates and everything, and the input that it's requiring is the actual date format, which is year, month, and year. But let's say it's sending the string as an input instead, like tomorrow or day after. That's not going to work because the tool will expect it to be in a certain input format. So this is another place where tools can tend to cause issues and the agents can fail. And finally, it can also misinterpret the output. So oftentimes when it's interacting with all of these tools, even if the tool is giving like an error message, the agent can treat it as a successful outcome. So it leads to a cascade of failures effect, and hence, again, these are challenges that we have to figure out and try to overcome. And finally, it's the environment itself. So the world is not clean and it's not very in a constructed way. So there is oftentimes issues with your external systems and sources of data that you're connecting your agent with. So these external systems can be in an unexpected state. So let's say you are connecting your agent to some web API service, and that API service is down. And that, again, is causing a failure in your agent to perform because it's unable to access that website. So its dependency on those external systems also tend to be a reason of failure because it's trying to access that website API backend, or it's trying to access your internal database if you've given it access to that. And let's say your database is getting upgraded, or for some reason the IT team has temporarily made it unavailable, then all of these lead into an unexpected state for the agent. So, and also the task itself can get so complicated sometimes because it's doing so much back and forth across multiple tools that what happens is when it's using the LLM as its computational engine, it can often fall out of the context limit of the LLM. So this, again, is what we refer to as context overload, especially when it's being exposed to multiple tools where it needs to parse the information from all of these tools put together. So now that we know about these challenges, how do we actually fix this and what can we do? What we think is that you need a more collaborative AI system. So what we mean by that is to build a system or an ecosystem allowing your agents, your tools, and your LLMs to communicate and work together seamlessly so that you have a more collaborative, robust system rather than having a monolithic system where each of them are sort of independent of each other. So in order to mitigate the failures of the LLM itself, where the reasoning capabilities of it, instead of relying on a single LLM, what you can do is try to decompose your task. So if you're doing some kind of a complex task, we try to break them down into subtasks so that it's more efficient to route the use case into those subtasks and then make sure that the LLM is able to not generalize it, but rather be more specific in how it wants to perform those tasks. So that's what we mean by specialization, so having a more specialized agent to do it. The other way where we can try to help and reduce the errors of the tools is standardization. So using standardization protocols to establish communication between agents and tools. And this is where we're going to be focusing more on. So Yuan will be introducing you to some standardization protocols, especially MCP, that we will be discussing. So incorporating these protocols as you build your AI systems is going to really help mitigate some of these issues. And finally, resilience. So instead of exposing your agents directly to these fragile or isolated environments or dependencies that it has, we also need to think about having certain interfaces that it can fall back to so that if it runs into an error, rather than just giving us some wrong outputs out of it, we have certain structured way of processing those errors or figuring out if we need to reroute those tasks somewhere else, and basically give a more structured way of processing these error signals so that it can efficiently continue and perform the task that it was originally asked to work on. So with that, I'll hand it to Yuan, who's going to introduce us about MCP.
Okay. So how MCP can actually help? Before talking about how it can help, let's start by introducing a little bit about MCP. It's called, it stands for Model Context Protocol. It's an open source standard developed by the AI research company called Anthropic. It's designed to solve the core problem of AI applications. Think of it as a universal translator or rulebook that allows different AI agents, models, tools to collaborate. And it's like the USB-C port for electronic devices. It's just similar for, it provides a standardized way to connect AI applications to external systems. So how MCP can actually help with this process to achieve this vision we want to make agent work. So for reasoning failure, with MCP, we can describe the capabilities with rich metadata, so orchestration can work together. And then for the tool failures, we can use MCP to help with register specialized tools and expert agents in a consistent way. And for tool failures, with MCP, we can isolate environment dependencies, shielding agents from breakage. So maybe it's still confusing. So how does MCP actually work? Think about it as a bridge. So on the top, we have the MCP host. You can think it as your AI application, or simply put, your agent script. And inside it, you can connect to multiple MCP clients, each one handling a connection. And in the bottom, we have MCP servers. We can have like one or multi-MCP servers. These MCP servers wrap external tools like GitHub tools, Slack tools, Gmail tools, depending on your setup. It can be an official MCP server, like the GitHub one, or you can self-host your own MCP server. Each client connects one-on-one to the server, and the server describes what it can do, its capability and the tool itself, and the client calls those tools through the standardized way through MCP protocol. The key idea here is no matter what's behind the server, whether it's API or any other services, you can just talk through the same protocol. Like you don't have to worry about like how this tool works. You just like talk through the same method. So that's why we want MCP, which gave us consistency, reliability, and make it much easier to scale up integration. And then we want to like maybe still very high level, and we want to ground this to a real scenario. Imagine we have an Amy, engineering team manager who leads a busy Project Phoenix engineering team. And the challenge is she spent 20, 30 minutes every morning checking their team's GitHub repo for new issues, and then summarize it to a Slack message and put to a Slack channel. And the goal here is we want to automate this whole process. We want to free Amy up to more important stuff and unblocking the team. So now we know the scenario. We want to show you how we implement this. Here, the user, Amy, wants to fetch latest GitHub issue and send a summarized report to the team Slack channel. And by integrating with the agent, which powered by large language model, the agent then uses two MCP servers. The first one is GitHub MCP server to actually fetch the related GitHub issues. And then large language model help us to formulate this tool output to a human understandable message. And then we want to use a Slack MCP server to actually post that message to the Slack channel. So here, this is a very high level diagram. And next, we want to break up the components. There are, in total, 5 main components. The first one is a large language model. It can be any model you can think about. Like here, we use an OpenAI model. It can be a Gemini model or your self-hosted model. Doesn't matter. And secondly, we want to have an agent framework. Here, we use the most popular long chain framework. to speed up the agent building process. It can be any other framework. Like Llama Stack or Crew AI or any other. And thirdly, we want to connect to MCP server. Here we use an official public GitHub MCP server and also a self-hosted Slack MCP server. And then we want to actually connect to those MCP servers. We need MCP client. In on-chain, they support this as a simple Python code. I will show you later. And finally, we want to have a user application, which is just a simple Python code. Now we cover the pieces, and I want to show you a little bit about the demo itself. It's going to be tricky. Okay, so here is the demo itself. Okay, I'm gonna run this live. Oh, where is it? Okay, so firstly, we want to import those packages. That's very simple, and then we want to load the environment variable. As I told earlier, we are using OpenAI model, so we need OpenAI API key, and then we want to connect to MCP server, so we need to know the URL for that. For GitHub MCP server, we need the personal access token to actually grant your access. And then we want to set up the MCP client. In on-chain, they support this as a simple Python code. For GitHub, you just selecting the right communication protocol. For example, the streamable HTTP and passing by the URL, and also the personal access token. For Slack, we are using standard I/O connection. And by loading these tools, we can see we've successfully loading over 100 tools from both both MCP servers. And then we want to initialize an agent. Here is a very simple agent using GPT model, passing by the tools, and then we give a personality prompt. You are just a helpful assistant. You can use Slack MCP server to post the message, and you can use GitHub MCP server to fetch the GitHub information. And then we break down the actual task. We want to pass by a URL, the GitHub repo URL, and then we create a query. Just simply put, you want to summarize this GitHub repo, and you want to return a meeting ready message following these rules. And by running this, you can see it's actually calling the correct GitHub MCP server tool called list issues, and then we return these. These two results, and finally we got a concise summary about yesterday's GitHub updates for this repo. And then we want to use, actually send this message to Slack channel. Here we can see we use a prompt training technique to passing the information we generated earlier, and we want to send this message to a demo, DevConf demo Slack channel. And then we can see here it's actually calling the Slack post message tool, and according to the large language model, return it's correctly posted, but let's see how it works. Okay, and then can you see it? It's actually sent through. Okay, let's come back. Oh, sorry. So in addition to the code itself, I also want to show a little bit about the setup. So for this demo, we set up two pods. The first pod is our code itself, and the second pod is Slack MCP server. We deploy this based on you can Google that Slack MCP server GitHub, like this one. Okay, yeah, you will find that in GitHub. It's open source, and then inside this Slack MCP server, you can actually go through the logs and see. just slow, a little bit slow. And here we can actually verify it's actually calling the tool. And that's it. So coming back from this demo, and let's move on to next. Oh, okay. Where is it? Okay. Okay. So we also want to like explain a little bit the lesson learned during the process. The first thing is we want to recommend start with defining the agent, the use case, not the agent. Start by asking yourself, like, what's the end-to-end business question like we need to solve? Map out the entire workflow first. And secondly, architecture over the algorithm. Spend less time trying to find the perfect model. Instead, we recommend spend more time in designing a robust system that specialized agents can communicate effectively. And third, standardization is the key. We want to recommend adopting protocols like MCP, A2A, which enables for scalability and future-proofing, pushing you towards an open and interoperable ecosystem. So for anyone who are interested in this, you can also go to these links. The first link is the MCP server GitHub repo. You can like go there, find some community provided MCP server or industry provided MCP server. And for the second link, you can try find out our experiment on using Llama Stack agentic framework with MCP servers. And the third link is our exploration in different agentic framework. You can find that there. Yeah, then that's our presentation, and thank you for your time to listening to this presentation. I hope this session gave you some idea about agents, MCP, and how they work together. I want to open up this floor and questions for us.
Any questions for Hema?
Would you talk about security concerns, or what happens? You gave the agent access to your GitHub.
Mm-hmm.
Is it just going to go delete a bunch of branches?
Like you in the personal access token, it's like any other personal access token, you can grant your access. So for our setting, we only grant read capability. So yeah. That's that.
So you can scope it based on the GitHub actions that you want to take.
Yeah.
But if you're interacting with other type of, this is just for GitHub example, but again, with different type of MCP tools and servers that you want to use, authentication is definitely something that's still being worked on. So our team is also actively looking at how do we improve the security when it comes to agents. And for example, it shouldn't leak tokens and cause it to call tools that it does not have access to. So we are also looking into that space. Definitely more to be done to make them more secure, I would say.
Yeah. Hello, thank you for the presentation, very interesting. You mentioned that it can be any self-hosted LLM, right? But actually it should have tool calling capabilities, right? That would be a requirement for this setup. Is that correct?
Yes, definitely selecting an LLM model that has sufficient tool calling. You can look at like the architecture of these models from Hugging Face, and you'll find like those model cards which explains whether it has tool calling capabilities or not. We just decided to experiment with an OpenAI model, but yeah, you can try with any other type of tool calling LLM.
Thank you. Sorry, maybe a second quick question about about multi-turn workflows. It's quite expensive, right, in terms of time and resources. So, based on your experience, have you found a way to overcome this or improve the efficiency on these multi-turn steps?
On like when it comes to multiple tools and multi-turn in general. Yeah, so in our experiments, they've been fairly, I would say, small. So we've kind of concised the use cases to be very specific and have only access to, let's say, at the most 3 or 5 tools. But yes, we have done different experiments on our team who've tried to test it out with, let's say, more than 20 tools and see what happens. And yeah, latency is a big issue when you have access to so many tools, and those back and forth interactions can cause problems. And of course, depending upon the size of the model that you're using, all of these again play a lot of different factors and role into it. But yeah, for this specific use case and example, we kept it very narrowly scoped so that it only has access to like 1 or 2 tools. Yeah.
Thank you.
I also want to add on that, like there are techniques like tool rack. You can like just like some sort of recommender system, but you stack a subset of tools.
I have one question. Can we granularize the access to only specific channel or specific file in the GitHub repo? Can we do that?
Yes, you can do that. So for example, for Slack, you need to authenticate a bot. So Slack has the option to configure like bots, if you might have been familiar with that. So you can specify what channels you wanted to get access to. You can set those settings within Slack. And then for GitHub, like Yuan mentioned, when you're giving that personal access token, you can restrict the type of scope at which you want the GitHub like tasks to be read from. You can even scope it to like issues or pull requests and those kind of things. So yeah, you can change those based on the type of MCP servers or tools you're using.
And in the program, it said that it loaded 102 tools, right? So what all tools are loaded? Because we only created like GitHub and Slack. So what all tools in extra it has to load?
Yes, great question. So in GitHub, the GitHub MCP server itself has a bunch of different tools. For example, just getting issues is one tool. Getting pull requests is a second tool. Getting issue comments is a tool. Getting PR reviews is a tool. So all of these put together, there are like a bunch of tools that you can enable. So what you can also do is you can also limit the number of tools you want to access within the MCP server itself. So if you don't want it to access everything, you can actually reduce, and like she said, you can make it access only a subset of the tools. So in our case, we just let it access everything. So that's why in combination with both Slack and MCP, it loaded like 100 tools. And in Slack, again, similarly, there are different actions it can do. So every action is almost treating it as an individual tool. So posting a message, reading a message, reacting to a message, all of these are individual tools that the MCP server has defined. And we didn't build these MCP servers. These are actually all community MCP servers. So that's the great thing about MCP servers is there's a lot of people out there who've already developed some MCP server, and you can just go and like try to access those. But you can also build your own as well. Yeah.
So when we load multiple tools, does it affect our latency and everything? Because we have to go through all the tools just to read the comments and read everything and then post it on Slack. So
Yeah.
here right now we are only accessing 2 things, just say GitHub and Slack, but we access like 5 things. We might have to load multiple tools, right? Like
Yes.
it can be around 500. So will it affect the latency and the power of GPU and everything?
It does, yes. So the more number of tools you give it access to, and the more it needs to, this was a very like fairly, I would say, simple query, but the more you try to expand your query and your task, it becomes harder for it to make those tool calls very quickly. So let's say it has to like call 20 tools together to come up with the response. There's definitely going to be latency. In this case, it was just making 2 tool calls, so it was doing it fairly quickly. But again, you can scope it to your use case to make sure that it's only using a subset of tools. That's one way you can overcome the latency issue instead of making it access everything. So a lot of research is being done to like limit the and the scope of the tools that you want to access for one single agent.
I have one last question. Yeah. How we can make it cost effective, right? Because if we load multiple tools, it will take a lot of latency and then multiple GPUs and everything. Yeah. So instead, why not I go and do that specific task, and why use an agent? How it will be more cost effective?
You want to take that?
Yeah, for GitHub MCP server, like they actually provide a public URL, and for issues, PRs, they have a like suffix. For example, the URL, it can be like just a GitHub MCP URL, and for if you only want to access issues related tools, you can have a suffix called issues, and that will limit you only using issue-related tools. Like that's one of the possible ways, or like you can just simply
You can also try to choose a smaller model.
Yeah.
We, of course, showed a larger OpenAI model, but you can do more with small models as well. It's all about how you break down the agents and how you break down the tools that a certain agent has. So it's not just like having one agent exposed to 50 tools, but it's thinking more along the lines of having an agent that's very specific to doing one task and only giving it access to those tools, and then splitting it up into multiple agents. Right now, we're only seeing single agent use cases, but in the future, it's definitely going to be multi-agents. So when we get to that, it's more about the cost optimization and figuring out like efficient ways to do those tasks.